Hello everyone, my name is Wei Guanghao, and the final project I want to present is email spam filter. Uh, in this presentation, first I will talk about the problem I'm starting now. I'm starting the problem, the topic is the email spam filter. As we all know, email is a cost-effective method of communication commonly found in all areas, and especially in the education industry. As we all know, workforce in education industry spends fair amount of time in front of computer chasing up on emails. This is more so with jobs that deal with higher volume of email each day, such as administrator in education industry. Managing incoming email is a critical matter to many because email can herald important meetings, work messages, launch industry-related information, and upcoming events, which this many cannot afford to miss. And this paper aimed to combine a spam filter which uses information gain calculation and context-based email classification model with the aim of improving the spam email classification accuracy to become 100%. And then I will talk about the some existing approaches, and I will combine this part with the performance of these approaches. First, a traditional approaches. Uh, the basic principle of this is based on the calculating information gain. But however, the problem with this solution is the accuracy in classifying non-spam email into folders. Out of many email learners used by the linker, this lead to an unstable accuracy, which moved between 48% to 28%. And when classifying email into folders. And then I will talk about the naive Bayes algorithm and the support vector machine, which tokenize the email for calculation, determining similarity of emails to either spam or other useful type of email. And experiments have found that removing stop words in emails improve accuracy of email classification. And um, a writer named Jason performed email classification using naive Bayes algorithm in an email classification system named iFile, and an email classification method named three phrase tournament method devised by Sayed, and it has shown a very unstable accuracy ranging from 2% to 95%. And the third part is ontology-based approaches. And the template is used to format your paper and style the text. And all merging, column weights, line spaces, and text fonts are prescribed. For example, the head margin in this template measures proportionally more than is customary, and this measurement and others are deliberate and using specifications that anticipate your paper as one part and entire proceeding and not as an independent document. And this shows about the same accuracy with the Bayes naive algorithm. And the fourth part, I will talk about the graph mining approaches. Graph mining approaches to email classification take advantage of semantic features and structure in emails by converting emails into graphics and matching template graphs with graphs made from each emails. Typical graph mining algorithm converts email into graphs. Substructures of graphs are then extracted from the graphs, and the parameter prone substructures representative substructure remain, and substructures are ranked just so that in case an email graph matches more than two representative substructures, An email go into the folder which the matched representative with higher rank. Email sift is a graph mining algorithm. This email classification accuracy increased from 80% to 95% as number of inputted email increased from 60 to 370. But on the contrary, a later work showed that the email classification accuracy decreased as the number of folders increased. Accuracy of email classification decreased from 100% to 91% as the number of folders increased from 2 to 4. And the last, I will talk about the current best selection solution. And it's also the graph mining solution. It's graph mining algorithm, and it's named context-based email classification system. It considers of graph mining algorithm and event identification system, as shown in the later part, as shown in this part. We can see the accuracy of email classification was 80% when 300 emails were. I will continue to show this page. Accuracy of email classification was 80% when 300 emails were used for training, and accuracy of email classification rose to 85 when 75 emails was used, and accuracy reached to 88 when 1,500 emails were used, and accuracy became 93% as the number of training emails counts 3,000. As a result shows, it took 10 times more email to raise accuracy from 80 to 93%. A major flaw in this system based on the huge number of emails it required to reach accuracy of 100%. Also, the context-based email classification model does not have spam homogeneous email into groups. This proposed work therefore need to address this insufficiently to improve the model. Email classification system named Linger. Linger uses neural network, and finally, this approach is named Linger IG, and as shown in this picture, and we can see the nearly 100% accuracy at the spam email classification. And the third part, I will talk about a new approach, and this approach is what I started in this project. This approach based on the neural network, and it's named the context-based email classification model. Is like the best solution we showed in last part. And activity at each stages of email classification is shown below in the figure 1. This is like that, and this system consists of 3 stages: email processing, pre-processing, filter extraction, and email classification. The proposed system runs pause trigger on email in email pre-processing stage to turn email texts into email features, and at features extraction stage, proposed system filters them from the set of inputted emails. Then, from filtered emails, sign of words, greeting words, keywords are extracted to form email graph. At this stage, template graph update using new email graphs, and template graph are then ranked in email classification stage to be assigned to represent relevant folder. Then email graphs are matched to representative template graphs and placed to folder of the representative template graph that graph matches most. And the detailed diagram of this proposed work is presented in the figure 2 as I show in here. And this is three step of this system we have talked before. And we covered about this performance before, and I will talk about the performance of my solution. And I can show you in the I can show you the code. First, I will create the feature, and this is my code. First, here we can see the feature is successfully created, and then I will test the final accuracy of the data by using RNN. And here is it. And we can see from the third epoch, the accuracy is can reach to the 100%. And we can also see the average accuracy is about 88%. So it means when the as the uh, data increases and the training time increases, it will eventually reach to the 100% accuracy. And then we go back to the PowerPoint. And here we can show I show the accuracy time by a format. And finally, I will conclude of my project. This paper has identified that 100 accuracy in spam classification of email system is still an unmet need. Project has drawn upon the work of the existing email classification systems known as a context-based email classification system and lingered to address the unmet need. And main steps of the context-based email classification system begins with pre-processing email using pulse trigger. Then it extracts several email features to transform emails into graphs, and then graphs are matched to representative graph so that email are classified to the folder which the representative graphs which highest match represent. And Linger implements information gain classifier for filtering spam and use neural network to classify email into homogeneous clusters. The proposed system adopts a spam filter from Linger to reinforce the accuracy needed to separate spam emails without any mistake. And proposed solution provides 100% accuracy at filtering spam from a set of mixed emails. As far as the experiment shows, processing times between using spam filter and not using spam filter differ insignificantly. It is important however, to stress the need of reduced processing time of spam classification because processing time of 0.1 second is an unmet need in this solution. And that's all of my presentation of my final project. Thank you.